You're welcome once again to a very interesting topic. This is the third topic in the series of General Agriculture lecture, and I still remain your facilitator, Yusuf Alawide. In the first topic, we discussed extensively on the definition of agriculture and the types of agriculture. In the second topic, we discussed extensively also on land tenure and land tenure systems. And this third topic promises to be a very interesting one. We'll be discussing more on the classification of crops. We'll be classifying crops based on their botanical characteristics. We'll be classifying crops based on the duration of their crop growth, and classification will also be based on the economic or agronomic importance. This course promises to be a very interesting one, and I promise that you have a very lovely time. Let's go and have a jolly ride with me. Thank you very much. You're welcome once again. Like I said in the introductory slide, we'll be going on a jolly ride, and this is the third topic on General Agriculture AGR 201. I still remain your facilitator, Alawuddin Yetunde. So let's go on. The first thing we'll be discussing about here is the classes of crops. Classes of crops, and by grouping of crops that evolved from domestication of wild ancestors. We have a lot of crops in the wild, but they are domesticated so that we'll be able to have access to them, and they will be able to feed the growing population to satisfy man's need for food and non-food purposes. Also, classification is due to the economic importance of the consumable part of the plant. So classification of crops is very important because of the domestication from wild ancestors, and also for their economic importance. That is talking about this slide. Moving to the next slide now. Classification based on nomenclature. That will be the first kind of classification we'll be talking about, because in this topic we'll be dealing more on the classes of foods, classes of crops, and plant uses. Okay, so the first classification is based on nomenclature. That means the binomial system. And the king of all this classification is Linus. And what he did was to classify crops based on divisions. So we have the topmost being divisions, then subdivisions, classes, orders, families, genera, species, subspecies, and varieties. So this is how to classify crops in that order. We have the plant the divisions, subdivisions, classes, orders, families, genera, species, subspecies, and varieties. And also, plants are either seed producing, that is the Spermatophyta family, or non-seed producing, that means some plants actually do not produce seeds like the viruses, the bacteria, and all those microorganisms. So these spermatophytes right now, that's the seed producing crop, are the most highly evolved and they are structurally complex. However, they can be separated further into two classes. You know, we are talking about classes. The first class is the gymnosperm, and just like you can see in the picture here, the plants produce naked seeds. They don't usually produce flowers, okay? They are not usually attractive. They are not attractive rather. So they produce naked seeds and they are usually cones. Okay, you can see in the picture here that the cones are here. This is a pine tree, these are the cones, and they are usually the female organs. So they exhibit structural adaptation to reduce water loss. That means you can see from their leaves here, very, very thin and all that. So they kind of adapt to severe conditions because of all these features. And in this group of plants, the gymnosperm, we have the coniferas, we have the clipiogas. Another class we are talking about is the angiosperm. The first class we talked about the gymnosperm, and the next one we'll be talking about is the angiosperm, and these ones produce seeds. They are plants which produce seeds, and they are usually protected by fruits and they have flowers. So they reproduce by sexual reproduction. You know, they produce attractive flowers. So what happens is that if they attract insects, so insects will now come, bring pollen from another crop, come and fertilize the stigma. You know, they have a well structured kind of reproductive system and they produce sexually. And most of the families are important to our horticulture, the flowers, you know, daisies, whatever they are, there are so many of them. So they are important to horticulture, both crop, plants, and weeds. This class, however, this angiosperm can be further divided. So they have the monocotyledons and the dicotyledon. Okay, so the first class of the angiosperm is the monocotyledon, and these monocotyledons, like you can see in this picture here, consist mainly of grasses. Okay, you can see the leaf structure. Okay, they are mostly grasses. They have thin veins. They have um, they are parallel. They have certain characteristics that make them to be called monocotyledons. And the ones that belong to the horticultural family are the Liliaceae, which consist of the tulips and the onions. Then you can see the Dadfold family. You can see the Iris family, the Iridaceae, then the Gramineae. That's all the grass species belong to this class. And the second class is the dicotyledon, and you can see like in this picture here we have further classes. Dicotyledons are split into so many. We have number one the compositae, we have the cruciferae, we have the rosaceae, we have the leguminosae. You know, all these belong to the dicotyledon family, and it's very important for you to give examples of these crops. You can see here the Brussels sprouts. You can see here the legumes, the beans. You can see apples here. You can see the flower, the horticultural plant here. They all belong to the also continuation of the dicotyledons. You can see the Solanaceae, which are the potatoes, the tomatoes, the cucurbitas, the cucurbitaceae, the Labitaceae, the Cactaceae. Okay, all these, they all belong to this class of dicotyledons. Like you can see in the picture here, these are potatoes, they belong to the Solanaceae family. These are the cucumbers, they belong to the Cucurbitaceae family. This is the Labitaceae family. These are mostly herbs, culinary herbs. Then you can see the Cactaceae family. These are the cactus, all manner of cactus. We have several species of them. So they belong to the subclass. So Leaving that classification, now we are moving on into another form of classification, and this is classification based on the botanical characteristics. Okay, previously we talked about different forms of classification, the geniosphere, the angiosperm. This is another kind of classification, and this is classifying crops based on the botanical characteristics. And under this classification, crops can be grouped into two, like we talked in the previous slide. We have the monocotyledons species of plants, and we have the dicotyledons species. The monocot have one seed leaf or one cotyledon, and you have an example in maize, while the dicot have two seed leaves or two cotyledons, and we have a great example in the cowpea. And these are some of the characteristics of the monocotyledon and the dicotyledon. The monocots have veins which are usually parallel. They are parallel veins, just like you can see in the leaves. You can see the parallel veins. Okay, and the vascular bundles are usually complex. They are usually arranged in a complex form. They have a fibrous root system. You can see it scattered, the fibrous root system, just like your maize, the crop root in maize. Okay, and in the dicotyledon species, we have their veins which are net-like. They have this net-like veination pattern. Then their vascular bundles are usually arranged in a ring. You can see, like in this picture here, it is in a ring form. And they have the taproot system. You can see the root grows in deep down like that, and you have a good example in the cowpea. So that is talking about classification based on the pot. Another form of classification is based on duration of crop growth. Okay, crops have different duration of growth. All crops do not have the same kind of duration. Some complete their life cycle within a year. Some crops complete their life cycle in 2 years. Some crops keep producing over and over and over the years. So we have to classify these crops based on their growth pattern. And the first classification here is the annuals. And the annuals are crops which complete their life cycle in 1 year. Okay, it can be 3 months, it can be 4 months, but it has to be in 1 year. And we have examples being the maize, the cowpea, the tomatoes, the soybeans, the amaranthus, okra, yam, so on and so forth. You can name it, you can go on and on and on. Then you have another group of plants which are the biennials, and these crops complete their life cycle within 2 years. And an example, a good example of this is the cassava and the brassicas. Okay, these crops complete, they grow vegetatively for a year, then they now produce seed the following year. So their growth cycle is usually 2 years. And they have the third classification, which are the perennials. And just like their name is, they grow on and on. They live for more than 2 years. Okay, the trees are there, they keep fruiting over and over and over, and they're mostly tree crops. Okay, so they keep producing fruit year in, year out, year in, year out. An examples of this is the cacao, the rubber tree, plantain, oil palm, ginger, sugarcane. They just keep growing over, and you keep harvesting over. Another form of classification, which is quite vast, very quite lengthy, is classification based on the economic or agronomic importance. Okay, all crops have their economic and agronomic importance. It's very important that you should note this. All crops, some are useful for food, some are useful for fiber, some are for all kind of purposes. So classification of crops is based on economic or agronomic um, importance. And we have, we'll be talking about is the starch plants. Okay, and these crops are grown primarily for high calorific value in human diets as starch, carbohydrates, and sugar. These type of crops are energy giving. They are the starch. They are the crops that are grown for their high calorie. They have very, very high calorie, and it is important in giving energy in human diet as starch, carbohydrates, and sugar. And these crops, however, constitute a larger part of the crop and is usually processed into pure starch, which is used in industries for sizing threads and for starching cloth, for finishing of cloth. There's so many uses of starch. You use them on your cloth, you use them on your fabrics, and they are used industrially also. So these starch plants are very, very, very important. They have high energy, high calorie, and they can also be converted into starch. And you have examples here being the cassava, the potatoes, the plantain, the maize. This We also have other uses of starch plants. They can be used in the pharmaceutical industry, and they can be prepared as powder for cosmetics, for medicines. They can be used for glues, for dextrin, filter as dextrin, cornstarch, dextrose, maltose, just name it. Just name it. They have so many uses in the pharmaceutical industry, even in our diet, in animal feed. They have so many uses, and they constitute a very, very large portion of the crops. And examples, we have the maize, the rice, like I showed you in the previous slide, the cassava, the root crops, okay, the pseudo cereals, which are the rye and the oats. Then we have the tubers, which are yams and sweet potato and others. We have the banana, the breadfruit, the plantain. Here in this slide, you can see this is dextrin and this is cornstarch. Okay, classification of plants that we have are the sugar plants. Just like the name is, they are grown essentially for the production of sugar. And you know what sugar does in our diet. They are used for sweetening drinks, for baking, for enhancing flavor. And they are used in many food preparations, in canning industries, in production of sweets. It's very, very important in the because many people have sweet tooth, many people love sweet things, and just enhances flavor generally. And we have examples of these crops like sugar cane, like you can see in the picture here. We have sorghum, we have sugar beet, and we have the agave. These are plants that belong. So the next one we'll be talking about are the oil plants. And just like the name is, they are grown essentially for their oil supply. These are crops that you can extract oil from. Okay, they are grown essentially for their oil supply. They supply edible oil, and they supply vitamin A because um, oils are usually rich in vitamin A, vitamin E, okay, then the provitamins also. So they are used, they are grown essentially for their oil supplies. Examples of these oil plants are, most of the nuts. Okay, you have the granules, you can get your granule oil, you can get your vegetable oil, you can get your palm oil from oil palm, you can get oil from so many, cashew oil, you can even get oil from corn. We have the corn oil, we have sunflower oil. These are oil plants, and technically, these oils also can be used in making soaps and detergents. It's not only edible, but they can be used industrially for making soaps and um, detergents, and for making other suppositories as lightning and burning. Okay, so you can use them to cook. You can use them to as a form of energy. You know, these are used for. And we also have the protein giving plants. Protein giving plants are crops, okay? Protein providing plants, sorry. They are crops that are desired for their protein value in human diet, okay? And plant proteins, um, they are mostly insufficient in many crops. So protein is usually found in very small quantities in other plants, but there are certain crops that have, you know, quite a high percentage of protein, and they are called the true protein plants. We have the pulses, the cowpea, soybean, we have the pigeon pea, the lentils, the lupins. These are true protein plants. Like in the diagram, you can see in the picture, you can see here, this is soybeans. This is what soybeans looks like, very high in protein. Some go as high as 10, 18, even 20%, depending on how true the protein plants are. Because most of these plants lack amino acids. So when you see proteins, you try and appreciate them because they are very essential. Then we have the vegetables. Okay, this group of plants are usually found among crop species. Okay, they are found in a variety of crop species, to include cereals, seasonings, roots, and tuber, legumes, fruits. Vegetables are very important. They are very, you cannot deny the fact that vegetables are very important. They supply the fiber that you need. They act as a laxative. They act to flush the system, to cleanse from inside. Their use is uncountable. You can go on and on and on. They supply the vitamins. They are usually there so that you can be refreshed. Vegetables have a way, especially when they are consumed fresh and green. They have a way of stabilizing the body temperature, the body structure, and everything, giving everything the body needs. It is like a capsule in one, all encompassing. So vegetables are very important. They supply the minerals, the vitamins, some supply proteins, okay, and they are now the fruits are another category of another group of crops, and these crops are grown and eaten for their refreshing and aromatic taste. They are usually eaten raw. You don't need to cook them. They are refreshing. You take them, you feel refreshed, and they have this sweet smell. They have this nice smell, which gives pleasure to man and even animals. You usually have your preferences in this fruit. Some people like pineapples for some reason. Some like grapes, the oranges, kiwi. You know, they are all fruits. They are all fruits. Okay, they have an important role in human nutrition and health. Okay, they contain substances which regulate and stimulate food digestions, organic acids, which act as mild laxative because of the fiber. They are usually high in fiber also, diuretics, and pectins with phenolic compounds. They have these things are the ones that aid the digestion, okay, of now we move on to the nuts group, the nuts family. You can see in this picture here, there are so many kinds of nuts. You have the peanuts, you have the cashew nuts, you have the almonds, you have the hazelnuts, you have there are so many kinds of nuts in here. So these are fruits with dry shells. Okay, nuts are usually fruits with dry shells, like the hazelnut, and parts of fruits like the coconut, the walnut. These are walnuts. Okay, or seeds like the Brazil nut, which, due to their pleasant flavor, are eaten raw, roasted, or cooked. Okay, it's very important that most of the time they roast them, and you have to kill certain compounds that are quite poisonous by that process of roasting. So it's very important that you roast those that you're supposed to roast. You can eat very few raw, and some are usually cooked, like the peanuts. You can eat them either boiled or roasted. Okay, You can eat your cashew nuts also roasted. The almonds, you can eat them raw. Like I can remember when we used to be kids that time, we'll just take the fruits, we'll eat it, and then we'll crack the nuts and just eat the almonds inside. Or they can be dried or roasted. Okay? So thus they're widely used in confectionery as aromatic agents and in other foods. Yes, they are widely used as aromatic agents. They have flavors. You have the peanut flavor, you have the cashew flavor, you have the coconut flavor. You know, they are used as aromatic agents to enhance food, and they also have a high nutritional value in respect of energy and protein. So what they bring to the table when you eat your nuts, you get your energy and you get your proteins also. So other examples, you have the peanut, the chickpea, the sunflower seeds. Yeah, I think these are sunflower seeds. Then the cashew nuts, the chestnuts, almonds, you know, the pecans, the hazelnuts. They are so okay. Another group of crops are the beverages, the masticatories, and the stimulants. You have the beverages, masticatories, and the stimulants. And these are plants which contain certain chemical compounds that increase the physical and mental effectiveness. Okay, they also quench thirst and hunger, and they break down psychic inhibitions or produce fantastic dreams. Okay, this is what stimulants do, but it is important that you note that they should be used appropriately. They shouldn't be abused, because most times when these kind of stimulants or beverages are abused, then the it's usually very very bad, because when you now get used to all this cocaine, this drug addiction, all these heroin, these things that give you a feeling of fantasy, of pleasure, then it's usually wrong. It usually goes wrong at the end of the day. So they should be taking a little quantities just to act as a stimulant, like your coffee. As simple as coffee is, it could go wrong in one system when someone is addicted to it. So when you take your coffee, you take your beverages. Some people, because of some medical history or whatever, they take tobacco in very very minute quantities, but once one is addicted to it, then it's usually a problem. So these are the crops that belong to this kind of group. We have the coffee, we have the tobacco, we have coal. Now the next class of crops we'll be talking about is the spices. Okay, the spices, and they include all culinary herbs, seasonings, and condiments of vegetable origin. When we are talking spices, you're going into condiments. They are used in minute quantities just to enhance the taste, and they also have very high nutritive value. So they are used for improving the taste of foods in the food industry, the beverage industry, and technical raw materials. They also serve as medicinal plants. Okay, you can see the clove here, you can see the turmeric, you can see black pepper, you can see the garlic, you can see pepper, red pepper, chili. You can see your cinnamon stick here. You can see the cumin. This is also black pepper, the one that has been blended. You can see your cumin. You can see your thyme. You know, they are all spices. Nutmeg. You can see this leaf. What do they call this leaf again? The bay leaf. Yeah, you can see them. They are all spices. So this is what we call the spices family. They are used to improve the taste of food, and they also add medicinal value to your food. So when you take them, you take some amount of medicine into your system, and it does your system well. It flushes all the bad things in your system and just keeps you clean. And you have other examples to include the onion, the mustard, and all that. Okay, So what they do is that they stimulate the flow of saliva and secretion of enzymes in the stomach or in the intestine. Now, in the next slide, we'll be talking about the medicinal plants. Okay, and to the agriculturists, the most important medicinal plants are those containing active constituents which cannot be synthesized by the pharmacochemical industries. Okay, or if at all they can be synthesized, usually at a high cost. Or what you just do as an agriculturist when you have all these herbal medicinal plants around, you just go cut it and then you wash it, you clean it. Some that you have to boil, you boil. The one you have to blend, you blend. You know, it's always important to have these things around the house. You have the aloe vera, you can have mint, you can have ginger, whatever. You know, they are all medicinal plants. Okay, so they cannot be synthesized. Okay, and if at all it can be done by chemical industries, it's usually at a high, very high cost. We also have essential oils, and these are volatile substances. They're volatile substances, so when you keep them open like this, you know, it just vaporizes. Okay, we have examples like the turpentine oil, which is in this picture here. Then you have the camphor oil. So these volatile substances, what are they used for? They are used in the perfume industry. That's why when you spray your perfume on the body, it just vaporizes you, but the smell lingers depending on the fragrance that is inside the perfume. And you can also use it as in the cosmetic industry for soap. So and can also be used for technical purposes. That means that as solvents, you can use them as solvents to remove certain things, for masking smells of plastics, artificial leather, and talking about the fiber plants now. The fiber plants are also very important. Okay, when we talk about fiber, fibers are very important. They have high value in textile and cotton industry. You have fiber like the flax, the sun, the hemp, the cotton. This is the cotton. This is the jute. This is the sisal. You know, they are all the canaf. They are all fiber plants. Okay, you use them as floor coverings like the jute, the canaf, the agave, fiber, doormats. You use them for doormats. You use them as for making tear-proof paper, like the alfalfa grass, the brooms, the basket work. You use them as building materials, okay, like the sorghum, the agar fibers. These are all the uses. So the next group now is the elastomers. Okay, from the word elastic, elastomers. uh They are natural or synthetic polymers with rubber or elastic properties. You can see, like in this picture here, they are tapping latex from the tree. Tapping latex from the tree. So what these elastomers do is that they are usually natural or synthetic polymers with rubber or elastic properties, and then some of them are polyisopropenenes, which are either highly elastic or slightly elastic, but they have strong thermoplastic properties. They are very useful in making your knife handles, making tools, natural rubber for your vehicle tires, for packaging, you know, for brake pads, insulators, driving belts, golf balls. The use is endless. These are what. Now talking about the resins and gums, like you can see in this picture here, this is a gum tree. This gum is exudating latex. You can see the gum at the back of the tree. When we were growing up as children too, we used to have all these gum trees in our schools. We will now be picking them on the trees. We didn't really know the use, the importance there, but right now it is the importance. I know the importance. So resins are usually complicated mixtures of diterpenes with volatile serpenis. Okay, and the raisins are not usually separable from the gums. They are there, but most of them bond very well. So in plants, the liquid, the exudate, like you can see on this tree, is what they collect and then they process to get the raisins. Now we are moving on to the tannin materials, and these are also complex phenolic compounds. They are complex phenolic compounds with a large number of oxygen functions. Okay, they exist as hydrolyzable tannins. They can be hydrolyzable, whereas they can be hydrolyzed. Tannins like the AGR, like you can see in this picture here, this is an example of the AGR, or they can be condensed tannins made up of flavonoids, flavons, and catchings. All these things are what tannin materials are made of. Okay, and they are found in the parenchyma tissue of most plants, and they are usable in different concentrations, especially at the back of trees, wood trunks, and the like. So that is where you can get your. The next group is the dyes and colorings. Dyes and colorings, and these are plant pigments. They are found in plants. Most of these plants have their pigmentation. So what they do is that they extract this pigmentation and then they make dyes and tannins and coloring, sorry, out of them. Okay, so these plant pigments are found in plant cells, either in the plastids or in the vacuoles, and they belong to a variety of chemical groups, such as the anthocyanins. Okay, the anthocyanins, that's what gives the red pigment, the purple pigmentation, then the beta cyanins, that's the vitamin, and some carotenoids, that's what gives the orange color, like you have in the carrots. And the uses of dyes and colorings are you can use coloring and dye for anything. Use them on your clothes, use them beautifying your body, like we do in the Hausa tradition. It's what they call lali. Okay, they use it to beautify their bodies. They use it to decorate the homes. Use it even in baking, the edible kind of coloring. You use it in baking in the confectionery industry. The use is, and we also have the pesticides, and these are plants that contain natural protective compounds. Okay, and these natural protective compounds are used against insect pests and ectoparasites. Okay, like the neem tree, for example, that is an important plant that acts as a pesticide. You can use it to control mosquitoes, use it to control as an organic pesticide, use it to control pests. It's a very, very strong form of. Then you have the waxes. These waxes are fatty substances and they contain long chains of fatty acids with long chains of primary alcohols. And mostly what you use wax for is for your fruits. You wax them so that they can keep longer. They can have this very attractive they can be attractive to customers. So you use them in your citrus and apples. Then you use them in the cosmetic industry also. You also use them to make your lipsticks, your candles, your matches, paper industries, leather. Now talking about the forage and the pasture plants, we have been talking about most plants that are used for animals, for plants, I mean for humans in their diet. Now, when you're talking of forage and pasture, we're talking about animals, and these are plants that you can use to produce and to feed animals. They are produced for feeding animals, the domestic animals, and they include the silkworms, the bees, the insects. These plants are usually legumes or even grasses. Okay, and you have examples like your fodder melons. This, like in this picture here, this is a fodder that's been dried and they are started ready to give to the animals. So now we're talking about the ancillary plants. Okay, ancillary plants are such plants that are cultivated in agriculture or forestry, not for direct benefit to man, but we plant them to encourage the growth and development of other plants. That is what ancillary plants are all about. You don't really need them directly, but you plant them to encourage the growth of other plants. And the benefits that arise from planting such crops are soil improvement, ground covering, breaking or prevention of soil erosion. They serve as windbreaks, shade provision. And examples of these crops are the Robusta, Rivera Robusta, the black pepper, the bell pepper, and vanilla. So you can see in this picture, this is an example. There's the vanilla. This is what vanilla pods look like and the flower. So that is our so that is about the classification. The next thing we'll be looking about is the characteristics of tropical cropping systems. And it's important to note that tropical Africa lies south of the Sahara Desert. Okay, it lies south of the Sahara Desert and it extends over the entire equatorial belt of Africa, and latitudinally it extends to about 200 degree north and 260 degree south. We have 20 degree north, sorry, and 26 degree south. And it is that is very, very large expanse, okay? Thus exhibiting great diversity in form of relief, climate, and vegetation. So the diversity of these crops varies and depends on their cropping system or farming systems, okay, which has been attributed to multiple racial backgrounds, linguistic groupings, differences in cultural, economic, colonial, political background. For example, in the north, you cannot raise pigs because of their religious beliefs. So all these kind of crops that are grown depends on so many things. Differences in culture, in economic background, colonial background. Some people were colonized by the British, some were colonized by French people. So all these things have a toll on their culture. What are general characteristics of a tropical cropping system? Okay, when you're talking about true shifting cultivation, it's usually rare and is restricted to certain areas. True shifting cultivation in the rare sense, in the true sense, is rare and is restricted to certain areas. Then permanent cultivation occurs in compound farms, kitchen or homestead gardens where some soils are of high fertility. That is where, hardly in this Africa before you can see a house that doesn't have one form of garden or the other. Okay, so you have homestead gardens with high fertility, soil fertility, and the compound farm is the most widespread permanent cropping system. Okay, and is usually in nucleus of other field systems. Like I said earlier on, hardly before you can see a compound that doesn't produce that doesn't practice one form of agriculture or the other. You must plant something if you have space. So that is also we have the semi-permanent long and short bush or planted fallow. That is another characteristic of tropical cropping system, semi-permanent long bush or planted fallow system. Okay, where you're talking about semi-permanent long and short bush or planted fallow system, you're talking of either the long permanent or the short, depending on the kind of crop that is being planted. And the most important staple and cash crops are usually grown in the first year following the clearing of a forest. When you see a virgin forest and a farmer looks at this forest, this is what I want to plant. What they usually plant there is cash crop, your cocoa, your rubber, your oil palm. They plant it on virgin land so that you can maintain the forest, and is usually planted fallow or grassland. So another characteristic of a tropical cropping system is the mixed intercropping and relay intercropping. These are cropping systems that we'll be talking about later in the course. As we are moving forward, we'll be talking about it. So when you talk about mixed intercropping, you are talking about planting different crops at different intervals. And relay, when you plant one, you harvest one, you plant another one, you harvest another one, and you do it sequentially. You don't do it only cereals, you mix them with legumes so that you keep the soil fertility in system. So we have so many of them. We have so many of them in your course material, but because of time, I just have to select you. So when you go, you see most of them. I have a class activity also. I want you to just mention the groups, the main groups, the main classification of crops, and give me 5 characteristics of a tropical cropping system. I give you 10 minutes, 10 seconds to do that. I hope this lecture has been a very interesting one, and I hope to see you in the fourth lecture. Thank you for listening, and